In 2018, a 500-ton tanker ship tore loose from its moorings and slammed into the only bridge connecting Japan's most expensive airport to the mainland. Thousands of people were stranded. The runways were flooded. Access was cut off. For a few terrifying hours, it looked like the end of a $20 billion gamble. But the real story is not that Kansai International Airport flooded. It is that it was always built for a fight with the ocean. This is the story of the airport that is still sinking and the engineering miracle keeping it alive. To understand Kansai, you have to understand the pressure that created it. Osaka was growing fast. The city's old airport was boxed in by neighborhoods, trapped by noise complaints, and limited by the reality of urban density. In Japan, land is scarce, cities are crowded, and expansion is always expensive. So planners and engineers looked out over Osaka Bay and asked a dangerous question. What if the airport could be built on the sea itself? That idea sounds futuristic now. At the time, it sounded almost impossible. The site they chose was not solid ground. Beneath the bay floor sat a 20-meter thick layer of soft clay, the kind of seaweed that shifts, compresses, and slowly gives way under pressure. This was not a stable foundation. It was marine terrain that could swallow mistakes. Building an airport, there was like trying to place a city on a mattress made of wet sponge. Every runway, every terminal wall, every bridge, every fuel system would depend on ground that wanted to move. Still, Japan went forward. The first task was not the runway, it was the island. Engineers built a giant seawall to carve out a protected space from the ocean, then filled it with rock, gravel, sand, and earth until a new artificial platform emerged from the bay. This was land reclamation at a scale that felt almost unreal. According to the construction history behind this project, 3 entire mountains were partially removed to provide fill material. 3 mountains sacrificed to build an airport in the sea. That detail alone tells you what kind of project this was. This was not normal airport construction. This was nation-scale ambition made physical. Thousands of workers, barges, cranes, concrete caissons, survey teams, and marine construction crews spent years turning open water into airport ground. The island was not just being built, it was being invented. And for a while, the whole project looked like a triumph of human will. Then the sea answered back. The island began to sink. Not a little, not slowly enough to ignore. It settled the way a heavy object sinks into soft mud, inch by inch, relentlessly. The weight of the airport compressed the clay beneath it. Early estimates were grim. Reality became worse. Over time, Kansai settled more than 38 feet, or about 11.5 meters, since construction began. That is the height of a 3-story building swallowed by the earth. The airport was no longer a fixed structure. It had become a moving target. That is where Kansai stops being just a construction story and becomes something far more interesting. It became an engineering problem that never ended. By the late 1990s, the sinking was no longer just a calculation error. It was a catastrophe in slow motion. The airport was dropping about 50 centimeters a year. If they did nothing, the world's most expensive island would become the world's most expensive reef. So Japan did something remarkable. It decided to build a building that could walk. The solution was hydraulic jacking. More than 900 hydraulic jacks were built into the structure so sections of the terminal could be lifted and re-leveled as the island continued to settle. Think about that for a second. This airport was designed with its own correction system. It could be adjusted after construction, almost like a giant machine keeping itself balanced. That is not a normal building. That is an engineering organism. The logic behind it was simple and brilliant. Instead of pretending the island would stay perfectly level forever, Japan accepted the truth. The ground would move, the weight would shift, and the airport would need to adapt. So the design became flexible, modular, responsive. It was not built to resist change completely. It was built to survive it. That is the deeper genius of Kansai. Most people see the airport and think about size, cost, or spectacle. But the real story is maintenance. The real story is adaptation. The real story is that the airport was never treated as a finished object. It was treated like a living system under constant pressure. Then came the terminal itself, and the scale only became more impressive. The building was designed with sweeping curves and aerodynamic lines to help deflect strong winds and severe coastal weather. The terminal had to survive typhoons, storm surge, saltwater exposure, and long-term settlement. It was not just meant to look futuristic. It was meant to function in one of the harshest marine environments on Earth. Drainage systems had to be installed to keep floodwater moving away from critical areas. Structural elements had to account for the shifting island below. The runway had to remain level and precise for aircraft operations. The transportation links to the mainland had to be reliable enough for passengers, cargo, emergency crews, and maintenance teams. Every system had to work together in a place where the sea never stopped pressing against the edges. And every year, typhoon season reminded Japan that Kansai was not a normal airport. The airport sits in the path of extreme weather, and the terminal's curved form was designed to help the wind flow around it instead of slamming into it. The seawall had to be reinforced to handle wave energy and storm surge. Backup systems, flood protection, and structural monitoring became part of daily life. This was no ordinary aviation hub. It was a fortified island airport. Now here is the part that changes the entire story. By this point, the sinking was not just a design flaw anymore. It was a threat to the airport's future. And before the solution arrives, there is a darker question. What happens when a megaproject begins to lose the ground beneath it? What happens when the most expensive airport in the world starts dropping under its own weight? What happens when the sea wins a little every year? If you are still watching, this is where Kansai gets even more dramatic. The airport had to be kept alive while it was still sinking. That meant constant measurement, constant correction, and constant reinforcements. The island was monitored with sensors. The settlement was tracked in detail. Teams watched the structure the way doctors watch a patient in critical condition. Because in a project like this, maintenance is not an afterthought. Maintenance is the mission. Then came the test that made the world pay attention. In 2018, Typhoon Jebi slammed into the region with brutal force. Wind and water hit the airport hard. Flooding spread across the complex. Then, a tanker ship broke loose and smashed into Skygate Bridge, severing Kansai's connection to the mainland. Around 3,000 people were stranded on the island and had to be evacuated by boat and helicopter over 2 days. For a moment, it looked like the nightmare everyone had feared had finally arrived. But Kansai did not disappear. The bridge was badly damaged. Operations were disrupted. The airport was isolated. Yet the terminal itself survived. The structure held. The engineering did not collapse. The airport proved something important. Resilience is not the absence of disaster. Resilience is what remains standing after disaster arrives. That is why Kansai matters. Because this airport is more than a runway in the sea. It is a case study in coastal resilience, disaster preparedness, and the limits of human ambition. It shows how far modern construction can go when a nation is willing to spend years solving a problem that would stop most projects before they begin. And Kansai did not stop changing after the storm. The island keeps settling. The support systems still need inspection. The runway still needs monitoring. The seawall still needs reinforcement. The airport is under constant observation, as if engineers are in a long-term conversation with the ocean beneath it. It is part aviation hub, part coastal defense project, part geological experiment. That is what makes it so powerful as a symbol of Japanese engineering. It is not famous because it was built once. It is famous because it has to keep being saved. That lesson matters far beyond Osaka. As sea levels rise, storms intensify, and coastal cities rethink their future, the whole world is being forced to ask the same questions Japan asked here. What happens when land runs out? What happens when soft ground cannot be trusted? What happens when the coastline itself becomes unstable? Kansai is one possible answer. Not a cheap one, not an easy one, not a perfect one, but a real one. It proves that in the 21st century, we do not really beat nature. We negotiate with it. We build systems that can adapt. We create structures that can be lifted, reinforced, corrected, and kept alive long after the ribbon cutting is over. Kansai is not famous because it defies the ocean completely. It is famous because it keeps answering back. A normal airport ends when construction finishes. Kansai never really finished. It just entered the next phase of its life. An airport in the ocean. An airport on sinking land. An airport that became a lesson in resilience. So ask yourself this: if you had $20 billion, would you build an airport on sinking mud? Or is this just an engineering ego trip? Let me know in the comments. And if you lived in Osaka, would you trust this airport? Or would you still feel the ocean underneath you every time you landed?
Runway 6 right, cleared to land. Wind advisory in effect.